Hello my dear students, I warmly welcome you to CR Digital Classes. In this lecture, we are going to discussing problem based on the Runge Kutta method. In that one, the first method is the Runge Kutta second order method. So for the examination purpose, this method is very important. Let's see the question first of all. Using second order Runge Kutta method, compute the value of y of 0.1 and y of 0.2 given that the initial value problem is dy by dx is equal to y minus x with y of 0 is equal to 2 correct to the 4 decimal places. Okay, so the given function is dy by dx is equal to y minus x. Okay, and the given initial value condition is y of 0 is equal to 2. Okay, now what we have to find out, y of 0.1 and y of 0.2 values correct to 4 decimal places. Okay, so now see the solution. Second order RK method or Runge Kutta method. You can write the full form. Second order Runge Kutta method. Given differential equation is dy by dx is equal to y minus x, where f of x comma y is equal to y minus x. With the initial condition y of 0 is equal to 2. Y of 0 is equal to 2 means by comparing y of x naught is equal to y naught, we will get that x naught is equal to 0, y naught is equal to 2. Assume step size h is equal to 0.1. Assume step size h is equal to 0.1. Why? Because in this method also we have to assume the step size. Why? Because based on the given function value y of 0.1, 0.2 is there. Okay, so if you take h is equal to 0.1, then by Runge Kutta second order method formula is given as, so y suffix I plus 1 is equal to y suffix I plus 1 by 2 into k1 plus k2 for I is equal to 1, 2, 3 up to so on. Okay, so that is a general formula. Now in this formula, so first we are going to find out that y suffix 0.1. Okay, here k1 is equal to formula and we have to find out the k2 also. First k1 is equal to h into f of x naught comma y naught. Okay, so k1 is equal to h into, what is that, f of x naught comma y naught minus x naught, y naught minus x naught. Substitute the h value and y naught is 2, x naught is 0, so therefore k1 is equal to 0.2. Next to k2, what is the formula? H into f x naught plus h comma y naught plus k1. So substitute the corresponding values 0.1 f of x naught 0 plus 0.1 comma 2 plus 0.2. So therefore 0.1 f of 0.1 comma 2.2. So if you simplify that function, here this function is f of x naught comma y naught formula. Okay, f of x naught comma y naught, then you can write y minus x. Okay, so therefore 2.2 minus 0.1, 2.2. Here this value is the y naught and this value is the x naught, or y1 x1, y1 minus x1. So therefore 2.2 minus 0.1 into 0.1, you will get k2 value is 0.210. So substitute k1 k2 values in equation number 1. Then for first approximation I is equal to 0, what is the Runge Kutta method is y1 is equal to y naught plus 1 by 2 k1 plus k2. So therefore y1 is equal to y of 0.1 is equal to y naught 2 plus 1 by 2 into k1 0.2 plus k2 0.210. So therefore y of 0.1 is equal to, this is the value, so you can write y of 0.1 is equal to 2.205, 2.205. Okay, so in this format we can find the value of by using Runge Kutta second order method. Similarly y of 0.2 value, okay, here x1 is equal to 0.1 and y1, already we derived that y1 is equal to 2.205. How you can say x1 is equal to 0.1? Okay, why? Because it is depending upon the small h value, small h value. Okay, x1 is equal to x naught plus h. What is the x naught value? 0. What is the h value? 0.1. So therefore 0.1. Now then k1 is equal to h into f of x1 comma y1. Here for this value the formula will change and don't get confused. Okay, here k1, okay, you will get instead of h of f of x naught comma y naught. Okay, for the second approximation we are changing that formula, x1 y1 will come. Okay, so that is a small change you have to remember, 0.1 and f of 0.1 and 2.205. So therefore y1 minus x1, what is the function value? y1 minus x1. So therefore 2.205 minus 0.1, k1 is equal to 0.2105. So next similarly k2, h of f of x1 plus h comma y1 plus k1, y1 plus k1, substitute the corresponding values. Okay, so simplify, then you will get that k2 is equal to 0.2216. Here also you will get the function value y1 minus x1. So therefore this one is the value and this one is the value. So therefore now from equation number 1 we have for I is equal to 1, y2 is equal to y1 plus 1 by 2 k1 plus k2. Substitute in the corresponding value. So therefore y2 is equal to, what is the y2? Whenever you get the y2 value, y2 is equal to y of x2. Similarly, here y1 is equal to y of x1. So therefore that is the value. So therefore x1 is nothing but 0.1, x2 is nothing but 0.2. So therefore y2 value, y1 value 2.205 plus 1 by 2 into k1, k2 value. So therefore if you simplify them, y of 0.2 is equal to 2.4211. Okay, so this is the total method of Runge Kutta methods. అంటే ఇక్కడ మీరు కేర్ఫుల్ గా ఉండాల్సిన సిచ్యువేషన్ ఏంటంటే, ఇక్కడ మోర్ దాన్ 2-3 వాల్యూస్ అడిగాడు, మోర్ దాన్ 2 వాల్యూస్ అడిగాడు అనుకోండి, y ఆఫ్ 0.1 0.2 అంటే ఇక్కడ మీరు ఫార్ములా సబ్స్టిట్యూట్ చేసేటప్పుడు చాలా కేర్ఫుల్ గా ఉండాలి. చాలా మంది ఏం చేస్తారంటే k1 is equal to h into f of x0 comma y0 నే, ఇక్కడ కూడా x0 నే యూజ్ చేసే సిచ్యువేషన్స్ ఉంటాయి. ఓకే, సో అలా యూజ్ చేశారనుకోండి మీకు ప్రాబ్లం మిస్టేక్ అయిపోద్ది. కంపల్సరీ మీరు నెక్స్ట్ సెకండ్ వాల్యూ ఫైండ్ అవుట్ చేయడానికి పోయినప్పుడు మీకు వాల్యూ చేంజ్ అవుతుంది. నెక్స్ట్ మీరు ఫర్ ఎగ్జాంపుల్ y ఆఫ్ 0.3 ఫైండ్ అవుట్ చేస్తున్నారు నెక్స్ట్ వాల్యూ, అప్పుడు మీకు ఏమైపోద్ది, x2 is equal to మీకు 0.2 అవుతుంది. అప్పుడు y2 is equal to ఏమవుతుంది, ఇక్కడ వచ్చిన వాల్యూ మీకు y2 అవుతుంది. అప్పుడు మీకు ఫంక్షన్ ఏమైపోద్ది, k1 is equal to మీకు h into f of x2 comma y2 అలా అయిపోద్ది అనమాట, డిపెండింగ్ అపాన్. ఎందుకంటే ప్రీవియస్ దానికి వచ్చింది కదా వాల్యూ, ఆ వాల్యూని ఇక్కడ మనం నెక్స్ట్ అప్రాక్సిమేషన్ లో యూజ్ చేస్తాం. అది ఫస్ట్ అప్రాక్సిమేషన్ అనుకోండి, ఇది సెకండ్ అప్రాక్సిమేషన్ అనుకోండి. ఎందుకంటే ఫార్ములా సక్సెసివ్ ఫార్ములా, అది i is equal to 0 సబ్స్టిట్యూట్ చేస్తే ఫస్ట్ అప్రాక్సిమేషన్, i is equal to 1 సబ్స్టిట్యూట్ చేస్తే సెకండ్ అప్రాక్సిమేషన్, అలా వస్తుంది అనమాట. ఓకే, ఈ ఫార్మాట్ లో. ఓకే, సో therefore this is the total explanation of this problem. I hope you understood this problem very well. In the next lecture we are coming with the problem based on the Runge Kutta fourth order method. Okay, make a perfect practice, prepare well. Until bye, thank you.